Hello, and today's learning target is I can determine if two lines are parallel and I can write a line parallel to another. So parallel lines have equal slopes. I'm going to highlight that. They change by the same amount every time and they never intersect. So let's take a look at graphing the two lines right below. So I'm going to graph y equals negative 3x plus 2. So I'm going to go up 2 units and graph the y-intercept, and then I'll move according to the slope, which would be down 3 over 1. Again, down 3 units over 1. Or I could also go up 3 units to the left one, up 3 units, and then to the left one. And that would. Now I'll make that line, so here as straight as I can. And that would be the first equation. There, that's graphed, and now I'll graph the second equation and go down 1 unit for the y-intercept, right at negative 1, and then down 3 units over 1, and then, or I could also go up 3 units to the left one. And as you can see, it's very close to the other line, if I can make my line straight enough there, but it doesn't actually intersect, and they have the same slope. So those two lines are parallel, and again, we can figure out here that they're parallel too by the slopes, right? The number that's in front of x, and it's both a negative 3, so with different y-intercepts, those two lines are never going to cross, and they're parallel. So what do you notice about those two lines? Well, they have the same slope, they look very similar, but one just has a different y-intercept. So what is the relationship between the slopes of the lines? They have the same slope. So I'll write that down. And again, that is a big idea here for parallel lines, having the same slope. Again, that's m, or the number that's in front of the x variable. Now we are going to look at writing an equation that's for a line that's parallel to another line or another equation. So steps to writing a linear equation through a point parallel to a given line is 1, determine the slope of the parallel line. 2, plug x, y, and m into the slope-intercept form of y equals mx plus b. Step 3, solve for b. And step 4, write your final equation in slope-intercept form. And again, slope-intercept form was just noted up above, but y equals mx plus b. If you find rewriting linear equations easier, then you could write in point-slope form and rewrite to slope-intercept form. That would also work. But we're going to go through the steps that were above, and we'll write a linear equation parallel to the following lines through the given points. So I'm going to zoom in here, and we'll look at the first example. So parallel to y equals 4x minus 2 through the point negative 2, 2. So again, I'm going to highlight my slope, and that's 4. And then I have my x and y given the point. So into y equals mx plus b, I am going to plug in 2 for y, because that's what y is right there. M is 4, and I highlighted that in green because we want a line that's parallel to that line, so parallel lines have the same slope. And then x is negative 2, and we now need to solve, and x was right there, and we now need to solve for b, or the y-intercept. So I have 2 equals negative 8 plus b. I'll add 8 to both sides, and 2 plus 8 is 10. So 10 equals b, so if I rewrite this all together now, the last step in slope-intercept form, y equals 4x plus 10. So if we were to graph these two equations here and here, they would be parallel to each other, and the second line would go through the point negative 2, 2. So again, that y equals 4x plus 10 is parallel to the equation y equals 4x minus 2 that also goes through the point negative 2, 2. Let's try another example. So parallel to y equals 2/3 x plus 4, so I'm going to highlight 2/3, and then my point is x and, whoops, let's change that to not the highlighter, x and y. And so into y equals mx plus b, y will be -3, m will be -2/3, x will be 2, and then we'll solve for b. So -2/3 times 2 over 1 is, fix that right there, is -4/3. So I have -3 equals -4/3 plus b, and then we'll add 4/3 to both sides. And -3 plus 4/3 is -5/3. So if I rewrite this all together, I get y equals -2/3 x, and then minus 5/3, which I could rewrite if I wanted to, and write it as y equals -2/3 x minus 1 2/3. That would also work. So either one would be okay to write my final answer. Okay, let's look at the following, or the final example, the problem that's following. All right, so let's now write an equation that's parallel to y equals 1/3 x plus 1. So I'll highlight that slope. And then I now have x and y. So y equals mx plus b. Y is 4, so 4 equals 1/3. And then x is 6, and let's solve for b. So 1/3 of 6 is 2. So let's now subtract 2 from both sides, and b equals 2. So rewriting this all together, I get, I'll change colors here, y equals 1/3 x plus 2. So again, when we're writing an equation parallel to another equation that goes through a certain point, we got to remember the steps. So we'll determine the slope and use that same slope. Plug x, y, and m into y equals mx plus b. Solve for the new y-intercept, or b, and then write your final equation in slope-intercept form. Again, there's another way you could do this. Personally, this is the easiest way I feel, but this other way too, I'll show you an example in class, and be right there, that one. And then this was, again, the steps for writing a linear equation through a point parallel to a given line. Thanks for listening. Have a great day. Bye-bye.